All right, so it's my absolute pleasure to talk to you about my mini mission or big mission to make a cell-based model of the blood-brain barrier, which I'm going to call BBB for short because it's a very long name. So why would we even want a cell-based model of the blood-brain barrier? Well, first off, the blood-brain barrier it refers to these characteristics of our blood vessels in our brain where they're really, really tight. They don't let things pass through very easily. And this is great for our brain because it means that toxins and viruses and pathogens, they don't get into our brain. And when you eat a cupcake or you go for a run, that increased blood sugar in your blood isn't going to then activate all your neurons, which would be really hazardous, I'd imagine. And that's really great. But unfortunately, sometimes in disease, this barrier breaks down and it can sort of exacerbate a lot of symptoms in brain related disorders. And another thing is that when you have a really good drug, a drug that can target a brain disorder or reverse some symptoms, you might get through the clinical trials and then realize it doesn't actually pass through the blood-brain barrier, which is it's costly, it's disappointing, and it just makes these drugs take a lot more time to actually get passed through and passed on to patients. So what we really need is we need a model of the blood-brain barrier, and we need it to be fairly cheap. We need it to be very simple so that most people can handle it, not just a bioengineer or a biologist. And we also want it to be high throughput, so not some big clunky thing that you'd need a lot of space for or something like that. And so that's where my projects come in. And it's made me quite the bartender, and I'll explain why. So the first thing is to make it simple. As you can imagine, as you can see here in the blood-brain barrier, in the brain, these blood vessels are really close to neurons, and it turns out all these neurons in different cells, they give a lot of signals to these blood vessels to make them tight. So it's this interaction and talking between the cells that makes them do this. So what I do is I strip away all the cells. The cells are too complex, it's too expensive, and it's too difficult. And I instead try to isolate all of those little signals as if they're ingredients in a cocktail. And so then I feed my cells this cocktail of signals to see if that's going to make them a barrier. But as a bioengineer, I have another trick up my sleeve, and that's an understanding of plastics. I have one plastic in particular that's like a magical martini glass. That means that you get 5 times more drunk for whatever cocktail's in there. And so that's how this bodacious bioengineer bartender is going to battle the blood-brain barrier.